Starting a unit on probability. We're going to start with some definitions.
Delilah, is your brain on airplane mode? Maybe.
Okay, I'll give you guys a minute to copy this down. Okay, let's read this together. Any happening whose result is uncertain is called an experiment. The possible results of the experiment are outcomes. The set of all possible outcomes is the sample space, and any subcollection of a sample space is an event. Okay, so that's just some vocabulary for you to be aware of as we move into some examples. Example 1, the instructions are to find the sample space of each of the following. Part A, one coin is tossed. And we want to know what the sample space of this is. The sample space is the set of all possible outcomes. Okay, well, the first outcome that we could have when we toss one coin is the coin lands with heads up. We'll call that H, capital H. So then capital T would be the outcome where tails is up when the coin lands. So then our sample space, which we use a capital S, our sample space is just going to be a list of all the possible outcomes. We only have 2 here. So our list is just H and T. Part B, 2 coins are tossed. Okay, so let's list the possible outcomes. We could have the first and second coin, both of them land on heads. We could have the first coin lands on heads, the second coin lands on tails. They could both land on tails. Or we could have the first one land on tails and the second one land on heads. You might think that these 2 outcomes are the same because one lands on heads and one lands on tails, but it does matter which one lands on which. So these are technically 2 different outcomes that we could have because there's 2 different coins. The first one could land on heads and the second on tails, or the first one could land on tails and the second one land on heads. We have to list both of those as outcomes, even though it looks like it's the same thing. Okay, so our sample space is just going to list all 4 of these outcomes. Guess what part C is going to be? 3 coins are tossed. Okay, so rather than list all of our possible outcomes twice, let's just go ahead and list them within our sample space list. Okay, 3 coins are tossed. All 3 could land on heads. We could have the first 2 land on heads and the last one land on tails. We could have heads, tails, heads. And we could have tails, heads, heads. We could have all 3 of them land on tails. We could have tails, tails, heads. Tails, heads, tails. Heads, tails, tails. 8 possible outcomes. So again, if we look, all three of these outcomes may look the same because we have two heads and one tails in all three of these, but the order matters. It's the same thing with these three. It's two tails and one heads, but it's a different coin that's landing on heads each time. Okay, let's talk about the probability of an event. Okay, you guys get this copied down and then we'll talk about it. The probability of an event, if an event E has N of E equally likely outcomes and its sample space has N of S equally likely outcomes, then the probability of E is given by P of E equals N of E over N of S. All this means is that to find the probability of an event occurring, you count the number of outcomes where that event occurs or could occur, and then you put it over the total number of possible outcomes. So the number of chances that we have for something to happen is always going to be less than the number of total possible outcomes, which means this fraction is always going to end up being between 0 and 1. So probability is always going to be between 0 and 1, or from 0 to 1. It could also be 0 or 1, or anything in between. So it could be a fraction, it could be a decimal, or a percentage. Okay, we're going to look at another example. So this will be example 2. Here's part A. 2 coins are tossed. What is the probability that both land heads up? So E, this event that we're being asked about, the only outcome that would make this event true is if both coins land on heads. There's just one outcome that would make this event happen. The total, all the possible outcomes, the sample space, we listed in example 1. We said they could both land on heads, heads then tails, tails then heads, or they could both land on tails. So we listed that in example 1. So there's only one possible outcome that would make this event true, but there are 4 total possible outcomes. So to find the probability, the numerator is the number of outcomes that would make the event true, which we said that is 1. And the denominator is the total number of possible outcomes, which we said is 4. So the probability of both coins landing on heads is 1/4. Or we could write that as 0.25. It could also be written as 25%. All right, let's look at part B. No.
No?
Mm-mm. It's just not. Okay, part B says a card is drawn at random from a standard deck of playing cards. What is the probability that it is an ace? Okay, rather than listing all of the possible outcomes for this event and for the whole, we're not going to do that for this one. It would take quite a while to list all of the cards in a deck. I think we can do it without listing everything. So let's just look straight to the probability. Okay, so the numerator is the number of outcomes that would make this event true. So drawing an ace, the only, well, there's only 4 possible outcomes of drawing an ace, right? Because there's 4 aces in a deck of cards. The denominator is the total number of possible outcomes, which would be 52, because there's 52 cards in a deck. Yes. 4 over 52 can simplify to 1 over 13. If we wanted to change this to a decimal or percentage, 1 over 13 is about 0.0769. So that would be 7.69%. So if you draw a card at random out of a deck of cards, you have a 7.69% chance of it being an ace. Really, you have a 7.69% chance of it being any card, because there's 4 of each card in a deck. Okay, let's look at example 3. Okay, I'm going to just explain what's going on in this example to you. That way you don't have to write a whole bunch. So basically we have 2 12-sided dice, but a 12-sided dice in this example is not numbers 1 through 12 on a die. It's numbers 1 through 6 twice. So you've got 2 1s, 2 2s, 2 3s, and so on this 12-sided die. So what we're asking, or what we're being asked, is do you have the same probability of rolling any number on that die as you do just using a normal 6-sided die? So someone only has this weird 12-sided die and they want to know if they can still use it to play a regular game that just needs a 6-sided die, and the probabilities be the same. So let's compare. We have a 6-sided die. Yes. The probability of rolling any number on this 6-sided die is 1 over 6, correct?
Yeah.
You have a 1 in 6 chance of rolling a 1, 1 in 6 chance of rolling a 2, and so on. This 12-sided die that we're being asked about, which let's just go ahead and put in parentheses, numbers 1 through 6 are listed twice. So it's not numbers 1 through 12, it's numbers 1 through 6 listed twice. So the probability of rolling any number on this die would be 2 over 12. Because there's 2 1s out of the 12 numbers on the die, there's 2 2s, there's 2 3s, and so on listed on this 12-sided die. 2 over 12 can simplify to 1 over 6. So the probabilities for rolling each number are going to be the same no matter which of these that this person uses. Okay, one more example, and we will have to write a little bit on this one. Example 4, we're looking at the numbers of colleges and universities in different regions of the country. So the country has been split up into different regions, and then the number of colleges and universities in that region has been totaled up. So we're going to make a list of those. So we've got the Pacific region, the Mountain region, we've got West, North, Central, West, South, Central, East, North, Central, East, South, Central, then we've got South Atlantic, Mid-Atlantic, and New England. Okay, those are all the different regions of the country. The number of colleges and university in each of these regions. In the Pacific region, there are 581. In the Mountain region, there are 304. West, North, Central, 453. West, South, Central, 406. East, North, Central, 668. East, South, Central, 286. South Atlantic, 754. Mid-Atlantic, 630. And New England, 265. Okay, so the question. What is the probability that an institution chosen at random is in one of the 3 southern regions? Okay, so the probability of this happening, in the numerator, we need to total the number of colleges and universities that are in the 3 southern regions. So that would be West, South, Central, East, South, Central, and South Atlantic,
1446.
1446. So that's 406 plus 286 plus 754 in the numerator. In the denominator, we have to total up all of the possible outcomes. So all the possible outcomes are all of these numbers added together, which should be 4,347. So out of the 4,347 total colleges and universities in the country, 1,446 of them are in the 3 South regions. So that probability is about 0.3326. Or 33.26%. So if you were to list out all of the colleges and universities in the country and pick one at random, you have a 33.26% chance that that college or university is in the South, the 3 southern regions. Any questions on these examples? Any of these notes? Okay. I have a set of practice problems for you. So let me get that posted, and then I want to look at number 1 with you to get you started.